In section 9.7b, we're going to be factoring special cases, specifically the difference of two squares. As we begin this, all of our problems that are going to be factorable by the difference of two squares are going to be set up in a manner where we have a squared minus b squared, something squared minus something else squared. And this factors to what are called conjugates. And we've talked about this word before, I believe. And a conjugate has one term very similar to another term, but the only difference between those two terms is they factor to one being a minus in the middle and one being a plus in the middle. And once again, these terms are called conjugates. Conjugates factor to a plus b and a minus b. So what we're going to look for is a couple of these clues at the top. First of all, always look for a GCF. Always look for a GCF. Now, there's not going to often be a GCF, but if there is, we're going to factor it out first. And then we're going to do the rest of the problem, but we're going to bring that GCF along on each line. Second question you're going to ask is, are there only two terms? If so, are they both perfect squares? And lastly, is there a subtraction sign between the two terms? All right. If that's the case, the problem is factorable. If there's a sum sign, a plus sign in between those two terms, you need to realize the problem is not factorable and we just have to leave it the way it is. So let's look at some of these examples. Our first one is x squared minus 4. There are two terms. Number one, there is a minus sign between the two terms, and both terms are a square. And so this is going to factor into conjugates, x and x, plus and minus, and 2 times 2 is 4, so 2 times 2. Now just to show you how this works, the reason this works is because the outside and the inside give you negative 2x and positive 2x, which cancel out. But what's in blue is our answer. Let's look at our next one. The first one's a square, the second one's a square. So once again, we have x and x, plus and minus, and then 1 times 1. And the outside and the negative 1x and the inside positive 1x cancel. Our next one, two terms, both are squares. 169 is 13 squared. So we're going to have x and x, minus and plus. Notice it doesn't matter if it's plus or minus plus, and then 13 and 13. Our next one presents a little bit of an interesting situation where we have 64. So our first term is 8x squared. Our second term is 7 squared, but we're still having two different squares and then a minus in between. So we have 8x plus 7 and 8x minus 7. Now it's been about a minute or two since we talked about what these words are. Remember, this 8x plus 7 and 8x minus 7 are referred to as conjugates. All right, our last one, 100x squared minus 81y squared. Well, we're thinking what squared is 100x squared and what squared is 81y squared. Hopefully you realize that's a 10x, that's a 9y. So we factor this. 10x is going to be our front part of our difference of two squares, a minus and a plus, and then 9y at the back of each one. So here's 5 examples quickly of how to factor the difference of two squares. It happens rarely, but when they do come up, it's very quick to factor them, and I want you to be aware of that. Our second little section here involves looking at very similar problems that look like they are the difference of two squares. However, as we investigate them a little bit thoroughly and closely, we find that the first number of this is not a perfect square. Neither the 10 is, nor the 3 is, nor the 4 or the 11. Well, the 4 is, but we'll deal with that one separately. So as we start this problem, we have to think, first, find a GCF. and the GCF in this problem is 10. So what we're going to do is we're going to take that 10 out. That leaves me x squared minus 4, because 4 times 10 is 40. Now we bring the 10 down, and then we continue to factor. X and x, 2 and 2, plus and minus. You can't get rid of the 10 because it's part of one of the factors of the problem, and we have 3 factors here. Let's look at number 7. 3x squared minus 75. Let's think about what is the GCF between 3 and 75. Well, the GCF is 3, so we're going to take that 3 out, and that's going to leave us with x squared minus, well, 3 times 25 is 75, so 25. Since 25 is a perfect square and we have a minus in between, we can factor this as the difference of 2 squares. X minus 5, x plus 5, times a 3 on the outside. Number 8 presents an interesting situation because 4 and 400, as you know, are perfect squares, but we can also take a GCF out. So when that is possible, we always want to do that, and the GCF is 4. So we take that 4 out, and that's going to leave us with x squared minus 100. Keeping the 4 out front, we now have x plus 10 and x minus 10. Hopefully you're starting to see these patterns, and they make good sense. Number 9, once again, looking for a GCF. What's interesting here is, you notice we have x cubed and an x in the back. So the GCF is not just 11, it's 11x. And this is an example of having a variable as part of our GCF. So we have 11x times x squared minus 4 as our remaining difference of 2 squares. So we bring down the 11x, and we have x plus 2 and x minus 2. All right, so that kind of wraps up our difference of 2 squares. Our perfect square that we're going to learn today is 23 squared. And before we do 23 squared, let's just review a couple. Hopefully, I want you to think in your mind very quickly, what is 17 squared? I'll give you a minute to think through that. Hopefully you thought 289. Let's go up. 18 squared with your fingers. Think 3, 20, 4 on your fingers. 19 squared. Give you a moment to think of that. It ends in a 1, and 9 times 4 is 36, so 361. 20 squared, yes, that's 400. 21 squared, there's a 1 at the end, and it's 441. 22 squared, which is our one from yesterday, is 484. I like that one because the 4 plus the 4 is the 8 in the middle. And our one for today, 23 squared, is going to end in a 9, and it's going to be 529. So 529 is our perfect square for this problem. Your homework you're going to do for this section is page 493, 13 through 31 all, 32 through 35. And I would encourage you, before you start that homework, that you fill out this chart down here all the way down to 23. Time yourself and see how long that takes.